Hey there, students. In this clip, we're going to be going over 3 examples on how to factor difference of squares. Okay, so let's go ahead and write down the instructions for the examples first before we start. So we are to factor the following expressions, factor the following expressions, and then check your answers by expanding your result. Okay, by expanding your result. All right. So hopefully you end up with the question that you started with, okay? So let's take a look at question number 1. We're going to factor x squared minus y squared. All right, so anytime you're factoring a polynomial, the first thing you want to do is you want to see if there's a common factor, determine what the greatest common factor of the two terms are, and then extract that common factor before you factor what's left, okay? So what's the GCF of x squared and y squared? To determine it, we'll decompose both terms. So x squared can be factored into x times x minus y times y as a decomposed form of y squared. So why did we do this? Well, it enables us to determine if there are any common factors to be factored out. In this case, there are no common factors, so we can reassemble it into x squared minus y squared. Okay, now this is a difference of squares. How do we know that? Well, we have two squares, x squared and y squared, because their exponents are even, and we have a different symbol, a minus symbol here, okay? So we can use the formula a squared minus b squared equals simply the square root of the first and the last, and then the sum and difference of the result. So it's equal to a plus b times a minus b, okay? So we're going to apply the same principle here. Since this is a difference of squares, we'll root the first and the last, and then we'll add and subtract the square root. So we're going to have a plus b is going to be x plus y, and then a minus b will be x minus y. Okay? Because if you think about it, a is the square root of x squared, which is x, and b is the square root of y squared, which is y. So we just add and subtract these roots. Okay? So that gives us this result. All right, now we're going to check the accuracy of our answer by expansion. So title this check. This is our answer. What we're doing now is just checking. All right, so check. If I expand this, do I end up with the original problem? That's the question. So we're going to go x plus y times x minus y. And we're just going to follow this out, this double distribution, first, outer, inner, and then last, okay? So if we do that, x times x is x squared. X times y is negative xy. This first outer. Inner is going to be y times x, which is plus xy. And then y times y is negative y squared. These two terms in the middle are opposite, so they add up to 0. So your final answer is x squared minus y squared. Now, does this match what we started with? It absolutely does. So that means that our answer is correct. All right, so there you have it. All right, let's take a look at number 2. So for number 2, we're going to be factoring the expression. Let's see, 8x squared minus 18y squared. Okay? All right, first thing we want to determine is there a greatest common factor that we can extract from these two terms? To make it easy for us to determine the greatest common factor, we're going to decompose both numbers, okay? So let's start with 8. Let's find the prime factor decomposition of 8. You can take out 2 from 8 since it's even. You're left with 4. And then you can also take out 2 from 4 since it's even. You're left with 2. Okay? So 8x squared can be written as 2 times 2 times 2 times x minus 18. Let's break that down. Since it's even, we can take out 2. 2 times 9. And then for 9, we can take out 3, and we're left with 3. So 18 can be written as 2 times 3 times 3. And then y squared is simply y times y. Now, what is the greatest common factor here? You notice that 2 is common to both sides. 2 is common to both sides. So the GCF in this case is 2. So that's what we're going to be factoring out, okay? So we'll factor out the GCF, which is 2. we're going to be left with what's left inside, okay? Now let's determine what they are. So 2 times 2 times x is 4x squared minus 3 times y is 9y squared. Okay? Now if we look at this quantity in the parentheses, is this a difference of squares? We have a difference, which is good. 4 is a square, x squared is a square, so this first term is a square. 9 is a square, and y squared is a square, so the second term is a square. So in this case, we have a difference of squares, so we can use the formula a plus b and a minus b to find what the factored form is. Okay? So to factor this, we'll just simply root the first term and the last term, and then we add and subtract the square root of those squares. Okay? So we're going to have 2 times the square root of 4x squared is 2x. The square root of 9y squared is 3y. So we do the sum, and then we're going to do the difference of the same terms. Okay, so we have 2x minus 3y. So this is a factored form of the original expression, 8x squared minus 18y squared. Okay, now that we have our results, let's go ahead and do a check to determine if our factored form is accurate. Alright, so let's check. Hopefully we end up with the problem we started with. We're going to completely expand our results, 2x plus 3y times 2x minus 3y to see what we get. Okay? Alright, let's focus on the two parentheses first. We're going to double distribute or fold this out. First outer, inner, and then last. Okay, so when we do first, 2x times 2x is 4x squared. Outer, 2x times 3y is negative 6xy. And then inner is 3y times 2x is positive 6xy. And then last is plus 3y minus 3y is minus 9y squared. Okay? Let's not forget we have a 2 on the outside, so let's put the 2 there, parentheses. Let's try that again. Alright, and then we just combine this and see what we get. So when we add it downwards, this 2 on the outside stays alone, so we have a 2. 4x squared. These two terms are opposite, so they add up to 0, minus 9y squared. Okay? Now, does this match with the original problem? Absolutely not. You notice that the original problem doesn't have a parenthesis, so we have to do one more step, which is to distribute this 2 to both terms. Okay? So we'll do that distribution. We're going to have 8x squared minus 2 times 9 is 18y squared. Does that match with the original problem? It does. So we're confident that our answer is in fact correct. Okay? Alright, let's try one more example. Question number 3. What if we were to factor the expression? Alright, so for number 3, what if we had the expression of 24x squared minus 150y squared? Okay, so before ever we think about applying any formula to factor this, we want to ask ourselves, is there a greatest common factor that we can extract from these two terms in this polynomial expression? So in order to determine that, let's decompose both terms, okay? So let's start with 24. This is even, so I can extract 2. 2 goes into 24 12 times. This is even, I can take out another 2, left with 6. This is even, I can take out another 2, and left with 3. So the prime factor decomposition of 24 is 2 times 2 times 2 times 3. And then for the x squared, we just append x times x. Okay? And then for 150, this is even, so I can take out a 2. I'm left with 75. This number ends with a 5, so I can take out a 5. 5 goes into 75 15 times. And then this ends in 5. I can take out another 5, and we're left 3. 3 is prime, so we're done. So the decomposition of 150 using primes alone is 2 times 5 times 5 times 3 times, for the y square, y times y. Okay? So what's the greatest common factor here? So what's common to both sides? You notice we have 1, 2 on both sides. And we also have 1, 3 on both sides. So that tells me that the greatest common factor that I'm going to extract is 2 times 3, which is 6. Okay? So we're going to put the 6 outside, and it'll combine everything left. So 2 times 2 is 4, times x is x squared, minus 5 times 5 is 25, times y is y squared. Okay? Now this is a difference of squares. The quantity in the parentheses is a difference of squares because 4x squared, 25, and y squared all squared, they have a difference between these two terms. So to factor a difference of squares, we'll simply root the first term and the last term, and we'll add and subtract the square root of those terms. So we're going to have 6 times the square root of 4 is 2, square root of x squared is x, and then square root of 25y squared is 5y. So we'll do the plus first, plus 5y. This is a sum, and then the difference, the same two terms, but with a minus in the center, okay? Minus 5y. So this is the factored form of the original expression. Now, is our answer correct? We have to do a check to verify the accuracy of our factorization process. Okay, so let's check by expanding this answer and see if we arrive at the question. Okay, so 2x plus 6 times 2x plus 5y times 2x minus 5y. So what we're going to do here is just distribute. We're going to follow this out. First, outer, inner, last. And then when we're done following out these two quantities in the parentheses, we'll distribute the 6 to our result. Okay, so bring out a 6. 2x times 2x is 4x squared. 2x times 5 is minus 10xy. 5y times 2x is positive 10xy. And then negative positive 5y times negative 5y for the last is negative 25y squared. Okay, now let's go ahead and combine these, simplify this polynomial expression that we just generated by FOILing. So we're going to have, bring down the 6, 4x squared. These two terms are opposite, so they add up to 0, and they end up with minus 25y squared. Now last but not the least, we just distribute 6 to these two terms in the parentheses. So we have 6 times 4 is 24. X squared minus 6 times 25 is 120 plus 30, which is 150 y squared. Okay, so does this match with our original problem? It certainly does, so we're confident that our answer is in fact correct by this check process. Okay? All right, so how well did you get this example? These examples that I just did. So I'd like you to try out the following problems, and then you can post your answers in the comment section below in this video to let me know what you got so I can see if you've mastered it or not. Okay, so I'd like you to try these problems. The assignment or the instructions is to factor and check. Okay, just like we just did with these problems over here. So we're going to factor and check. Now for number 1, you're going to do z squared minus 49. For number 2 is 27y squared minus 12x squared. And then last but not the least, number 3 is 16s squared minus 36t squared. Okay, so what I'd like you to do is factor these completely and post your answer in the comment section below so I can know if you mastered the process or not. Okay, so there you have it. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here. And please post a comment to indicate your answers to the problem I posted earlier, or to let me know what you think about this presentation. More clips can be found on mathserve.com. Thanks again for watching, and have a wonderful day.